Hello everyone, this is a class on electrical machines and the topic is synchronous machines. So in this class we will be covering the basics of synchronous machine. So what is a synchronous machine? Synchronous machine is a machine that works at a particular speed and that speed is known as synchronous speed. Okay, now synchronous machine is a machine that works at synchronous speed. Synchronous machine works at a particular speed. Synchronous machine works at a particular speed and this speed is known as synchronous speed. And so this machine is known as synchronous machine. Okay. Now synchronous machine can be synchronous generator or and synchronous motor. Okay. Synchronous, first we'll see synchronous generator. Synchronous generator is also known as alternator. Okay. So what is synchronous generator? Synchronous generator is a doubly excited generator that converts mechanical energy into electrical energy. We all know that a generator converts mechanical energy into electrical energy. Mechanical energy is converted to electrical energy. And the synchronous generator is a doubly excited generator. Doubly excited generator. What is a doubly excited generator? Doubly excited generator is a machine in which the rotor and stator both are connected to separate supply. Okay, next we'll see synchronous motor. Okay, what is a motor does? Motor converts electrical energy into mechanical energy. Converts electrical energy into mechanical energy. Okay, this is also doubly excited. So synchronous motor is a doubly excited motor. Doubly excited motor. Doubly excited means I have already said that the rotor and stator both are connected to separate supply. So this is about synchronous machines. Now we'll see the different parts of a synchronous machine. That is, it has two parts, that is stator and rotor. First we'll see the different parts, that is first part is stator and the second part is rotor. Okay. The stator is the stationary part and the rotor is the rotating part. So the stator is a stationary part whereas rotor is the rotating part. Next point. The stator carries the three-phase armature winding. The stator carries three-phase armature winding. The stator carries three-phase armature winding. And what does rotor carry? Rotor carries the field winding. Rotor carries the field winding. Third point. In both generator and motor, its armature winding carries the load current. Okay. The armature winding. We know that stator carries the armature winding. And the armature winding, what does it do? It carries the load current. We know that when this is carrying the load current, it will be heavier. Okay. So this it is heavier than the field winding. Its armature winding its armature winding carries the load current. So when it is carrying the load current, it will be heavier. Okay, then what in the case of rotor? It carries a field winding. Or the field winding is used to develop the field flux. So it is lighter than the armature winding. Okay. The field winding is used to develop field field flux. So it is lighter than the armature winding. So it is lighter. Okay. Okay. Now we'll see the fourth point. Due to the three-phase supply, there are four terminals R, Y, B and N. Okay, in the stator we are giving a three-phase supply. So there will be four terminals. Due to three-phase supply, there are four terminals, which are R, Y, B and N. Now in the case of rotor, we are giving DC supply. So there will be only two terminals. Here there is only two terminals due to DC supply. Now the last point. In stator, AC supply is required because it carries a three-phase armature winding. So AC supply is required. But what is in the case of rotor? Rotor carries a field winding. So only DC supply is required. So in the stator, AC supply is required. And in the case of rotor, DC supply is required. So this is the difference between the stator and rotor. So stator is the stationary part and rotor is the rotating part. And what does stator carry? Stator carries the three-phase armature winding and the rotor carries the field winding. Next point, in the case of stator, it carries the armature winding. So the armature winding, what do the armature winding do? It carries the load current. So when it is carrying the load current, it has to be heavier than the field winding. In the case of rotor, it carries the field winding. Field winding is used to develop field flux, so it is lighter. In this case of stator, we are giving three-phase supply, so there are four terminals. In the case of rotor, only two terminals are required due to DC supply. And the stator, AC supply is required, and in the rotor, DC supply is required. So this is a basic of synchronous machine.